All right, we're back. We're on page 185 of math analysis. We're talking about parametric equations, and we've gotten to the point now where I think we know enough to actually start trying to do things with them. So what we're going to try to do is learn how to make things move from one point to another point in a straight line. And it doesn't sound like much, but it's kind of a big deal because it'll allow us to start creating our own scenarios and have motion involved and things like that. So weirdly, the most interesting things we can do at this point are things that involve lines. And we're going to be moving with a constant velocity. So this is going to be an issue, right? We can't speed up and slow down because that'll require more calculus. We're not to that point yet. But we're going to be able to write the equation of a line in parametric form. And it's pretty neat. So let's see if we can do it. So lines in parametric equations. So it feels very similar to point slope form to me. What you have to do is you want to get used to the idea where you first think about x. So think of x, then think of y. And you don't really need to think of them together. And that's weird. That's just different from how you're used to lines working. But look, we want a line with a slope of 2/3 passing through the point 3, 5, right? So what I'm going to do is just kind of like sketch a line. So a line with a slope of 2/3 passing through the point 3,5. So I'm going to put the point 3,5 like right here. And now let's think about what a slope of 2/3 really represents, right? So it's the ratio of delta y to delta x. Remember when we had eccentricity in conics, it was like c over a, but it was the ratio of c to a. So seeing 2/3 doesn't mean that it's necessarily 2 and 3. It could be 4 and 6. It could be 2/3 and 1, or it could be 1 and 3/2. Like, we don't really know. We just know the ratio is 2 to 3. So I think the most logical thing to do is think, if I increase x by 3, I will increase y by 2, right? Over 3 up 2. So another point on this would definitely be over 3 up 2. I could do that again, over 3 up 2. And we have all of these points now. There's an infinite number of points. I could also potentially go backwards, right? I could go back 3 down 2. So if I did that, that would take me to 0, 3. And for each and every one of these, I have this delta y over delta x, right? And so what I'm going to do is I'm going to show here, right? My delta x is 3, and I don't know. I'll do this one too while I'm here. Delta x is 3, and then delta y is also, so I have a delta y. Delta y is 2. Delta y is 2. So we want to think just about x, then just about y. So how can I describe what's happening with x? Well, I could say that x is starting at 3, right? Because that's like the initial point. So think of it as like kind of being anchored there. So this gives me 3. And then what do? Well, I'm just going to keep adding multiples of 3. But it doesn't need to be an integer, so I'm just going to say plus 3t, right? And this is my delta x. And that's where that's coming from. What would I do for y? Well, y would be 5, because it starts there. Ooh, I don't know what color that was. It might have been this color. Definitely not. Uh-oh. Maybe this. Nope. All right, one more shot. I think this. I think 5, and then what's y changing by? Y is changing by 2t, right? So I start at 5, and then I'll be at 7, which is this, and then I'll be at 9, because just keep adding 2. I know that if t is equal to 0.5 in this case, then, hold on, I was gonna highlight something. This is this color because of our delta y. Okay, so this will actually, if I say that t is an element of the reals, this will give me every point. It's just a question of like what t value I need, right? If x is going to equal 0, so when x equals 0, that must mean that t is -1. If t is -1, then it's 5 minus 2, 3, 0, 3. I can get to x equals, I don't know, like x equals 0.5, right? X equals 0.5, so 0.5 goes here, and then subtract 3, divide by 2, 0.5? Let's say 1.5. I would need t to be -1/2. If t is -1/2, this is going to be 5 minus 1, which is 4, so 1.5, 4. You can just keep working these things out. So this is a set of parametric equations for this scenario. And what we have is delta y over delta x is going to be 2 over 3. I'm going to try to highlight that. So here, and then I'm pretty sure this. Oh, wrong color, wrong color. This, right? Delta y over delta x has to be 2 over 3. Well, any delta y over delta x that's 2 over 3 is going to work. So I also could say, for example, maybe x is 3 plus 6t. And y is 5 plus. So what did I do? I doubled this delta x, so I got to double this delta y to keep the ratio the same. 4t. Delta y over delta x is going to be 4 over 6, which is 2/3. Now what's happening here is that this set of parametric equations is twice as fast as this set of parametric equations. Because if t increases by 1 here, x increases by 3. If t increases by 1 here, x increases by 6, it goes twice as fast. So that's kind of an interesting idea. What if, you just pick anything you want, right? So I'm going to say x is equal to 3 plus, I'm going to say 7 t. So y is going to be 5 plus, I have to work it out, right? So I know that delta y over delta x is supposed to be 2/3. So now I have 2/3 equals delta y over 7, because that's what I made delta x. So I have to like think about these things. So I made this. So that means that delta y is going to be 14 over 3. So down here, I'm just going to put 14/3 t. And for all of these, t is an element of the reals. And if we simplify it, delta y over delta x is 14/3 divided by 7, which is 14 over 21, which is 2/3. So it still works. Do we need to use positives? We don't, right? We can have x equals 3 minus 3t, but I need delta y over delta x to be positive, so now I have to do -2t. Do we need to use the 0.35? We don't. We can use any point on the line. So like any point we found or any additional point. So I could use x equals 6, y equals 7, right? That was one of the points. And then take your pick of any of our delta y, delta x's, plus 6t, plus 4t. So this is starting in a different place and going at a different speed. Okay, so before I end this, what I'm going to do, and I'm probably going to regret it because it's going to make it really long, is I'm just going to switch over to GeoGebra and I'm going to plot a bunch of these. So let's see. I'm using GeoGebra Classic always. Also, it's really dark in here, it turns out. Just a dismal day, basically. Curve 3 plus 3t, comma 5 plus 2t, comma t. Let's go from like -10 to 10. And we get this. Okay, parametric equations for that line, sure. Curve 3 plus 5t, nope, 3 plus 6t. So this is the one that should go twice as fast. We won't see that because all we're seeing is the path. But if we see anything new, we definitely did it wrong. So you can kind of see that it just overlays it. Curve 3 plus 7t, 5 plus 14 over 3t. So that's kind of a weird one. That's because we chose delta x and solve for delta y. -10 to 10. Okay. Let's do, I'm going to do all of them. Then I'm going to try to put points on all of them, and then I'm going to make a move. And it's not going to show you anything, but it's kind of fun to do. So, you know, there's that. Still the same. Like ideally, everything that we plot, we will not see anything because they should all just be like on top of each other. 7 plus 4t, t. negative 10 to 10. Okay, so now what I want to do is create a slider. I'll call the slider V and just let's let V go negative 10 to 10, right? Because that's what we're doing. So negative 10 to 10. I don't care about step sizes. In general, I don't really care about step sizes. I'd like this to be 0 though. Okay, oh no. Click it and then like tab. Sometimes you can. Grr. Oh, you know what you can do? You can just click here, change this to 0, and it's good. Okay. So now I got to do A of V, B of V, C of V, D of V, E of V. I don't know how many I made. F of V. Unknown. Okay, I guess that was all. Where are my points? Oh, okay. So all of my points. Well, they're pretty much all at 3, 5 because that's like the initial point I use for everything. One of them is at 6, 7 because I based a line on that. And then negative 10 to 10 is like way too much. But anyway, I'm gonna hit play and you can see we just have a lot of points that are following this line going like every which way, going at different speeds. That's the idea. So what we want to do is just learn more so that we can control like how are they going, what speeds, what are our objectives. Maybe we want to get to x equals 30 and we want to get there by like t equals 5, something like that. That's what we want to do. So I'll stop this. I'll go back to the notes, come back in the next video and try the next problem, finish the page hopefully. But I think that this is a really good introduction. The key is the delta x's and the delta y's. You figure out your delta x's and delta y's, you're good to go. So I'm going to end this here, and I will see you in the next video.